Hey guys, so in this lecture, I just wanted to talk about some deployment targets in the enterprise of Kubernetes. So, Kubernetes may be deployed in a variety of environments utilizing different deployment patterns as more teams and organizations are using. It's important to identify the implementations that they are most likely to adopt. There are several deployment models for running production workloads that vendors have already targeted with a suite of products and services. Now, this section, or whatever we are discussing now, highlights these models. So, it includes number one, manage Kubernetes and container as a service, public cloud and infrastructure as a service, on prem and data centers, and finally, hybrid deployments. So, manage Kubernetes and containers as a service. Let's discuss about it. Now, a managed Kubernetes cluster is hosted, maintained, and managed. By a commercial vendor. Based on past concept, this delivery model is called, container as a service architecture, as you can see on this screen. Now, on the screen, you see the component that make up the architecture uh, of a CAS solutions. So, container as a service, it offers service level agreement driven high availability and scalability of infrastructure. Now, CAS goes beyond exposing the basic cluster to users. Google Container Engine, which is GKE, Amazon EC2 Container Service, Azure Container Service, and Rackspace Carina are some of the example of CAS in public cloud. Often it comes with other essential services such as image registry, L4 and L7 load balancers, persistent block storage, health monitoring, managed databases, integrated loggings and monitoring, auto scaling of pods and nodes, and support for end-to-end application lifecycle management. Apart from CAS, Kubernetes is also offered as service via the public cloud. Many customers get started with Kubernetes through Google Container Engine, as it was one of the first commercially managed Kubernetes offering in the public cloud. Managed and maintained by Google, GKE delivers automated deliver container manage and integration. Just to get a idea of that. So, with other Google Cloud services such as logging, monitoring, container registry, persistent disk, load balancing, and VPN. Now, GKE only exposes the nodes of the Kubernetes cluster to customers while managing the master and etcd database itself. This allows users to focus on the application and avoid the burden of infrastructure maintenance. With GKE, scaling out a cluster by adding new nodes can be done within minutes. GKE can also upgrade the cluster to the latest version of Kubernetes, ensuring that the infrastructure is up to date. Customers can point tools such as kubectl to an existing GKE cluster to manage application deployments. Other hosted Kubernetes offering includes AppsCode, K-Cluster, and StackPoint Cloud. AppsCode delivers complete application lifecycle management of Kubernetes application while providing the choice of running the cluster on AWS or Google Cloud. K-Cluster is one of the emerging players in the hosted Kubernetes space. It runs on AWS with other cloud platforms support planned for the future. StackPoint Cloud focuses on rapid provisioning of cluster on AWS, Packet, DigitalOcean, Azure, and Google Cloud. It is built on open source tools including Tectonic, Prometheus, Prometheus, Dees, Fabricate, and Sysdig. Okay, now this shows hosted Kubernetes and PaaS solution available, and they are not all but some of them. So public cloud and infrastructure as a service. Apart from signing up for managed Kubernetes CAS running in the public cloud, customer can also deploy and configure the cluster themselves. They can choose a specific version of Kubernetes distribution and integrate it with the native features of infrastructure as a service, which is IaaS. Now, Core OS is one of the most preferred operating system used to run Kubernetes in the public cloud. The company has a comprehensive documentation and step-by-step guides for deploying Kubernetes in a variety of environments. With each release, Kubernetes is becoming easier to install. So in version 1.4, a new tool called KubeADM attempts to simplify the installation on machine running CentOS and Ubuntu. Customer can get a fully functional cluster running in just 4 steps. Now coming on to on-prem and data centers. Now, enterprise customers often prefer to run Kubernetes cluster inside a data center. This gives them the choice of using either virtualized infrastructure or bare metal server to deliver better performance. So when deploying Kubernetes behind a firewall, it is also important to consider the need and requirement for image and registry, image scanning, monitoring, and logging components. So these are commercial enterprise offering that provide these necessary components available in two different forms. One, commercial distributions and enterprise PaaS based on Kubernetes. Tectonic from Core OS and canonical distribution of Kubernetes are example of commercial distribution that are customized for enterprise deployment. Red Hat, OpenShift and Apprenda are application platform built on top of Kubernetes. They provide end-to-end application lifecycle management capabilities for cloud native applications. Okay, now let's quickly come to hybrid deployment. A hybrid deployment is an evolving use case with customers utilizing a Kubernetes deployment that spans the on-prem data center and public cloud. It leverages the virtual networking layer provided by the cloud vendor and the concept of federated cluster in Kubernetes. Kubernetes cluster federation can integrate cluster running across multiple zones and regions, or even clusters that are deployed on different cloud platforms. Federation creates a mechanism for multi-cluster geographical replication, which keeps the most critical services running even in the face of regional connectivity or data center failures. The hybrid architecture based on federated cluster enables organizations to run sensitive workloads within the data center while moving the internet facing elastic workload to the public cloud. With federation, customers are able to efficiently manage their deployment across multiple deployment targets and save on operating cost by dynamically optimizing deployment across multiple providers and regions. So I think this threw some light on on the topic we are studying. I think it gave a very good uh, purview and an idea of deployment targets in the enterprise. This is very important to understand because we are we started with very detailed digging of Kubernetes and its application management and things like that. Hope this was helpful. In the next lecture, we will talk about a few more technical and interesting aspects. Thank you very much.